Welcome to this lesson on experimental design and data collection. In statistics, how we collect data and design our experiments is absolutely crucial for drawing valid conclusions. Today, we'll explore different experimental designs and understand why some approaches work better than others. Let's start with why careful data collection matters. In most statistical studies, we can't possibly measure everyone or everything in the entire population. For example, we can't test a new medicine on every person in the world. Instead, we select a sample from that population. The key challenge is making sure this sample accurately represents the larger population. If our sample isn't chosen carefully, we risk introducing bias. Our results might then reflect how we selected our subjects rather than the actual effect we're trying to measure. Now, let's discuss a crucial concept in experimental design, the placebo. When testing a treatment like a new medication, we typically have a treatment group that receives the actual treatment and a control group that receives a placebo, an inert substance that looks identical to the treatment but has no active ingredients. The placebo is essential because it helps us isolate the true effect of the treatment from the psychological or other effects that might occur simply because subjects believe they're receiving treatment. This is known as the placebo effect. In well-designed studies, neither the participants nor the researchers know who's receiving the real treatment versus the placebo. This is called a double-blind design, which helps prevent bias. Let's examine different experimental designs, starting with a problematic approach. Here's an example of a bad experimental design. In this case, all women receive the treatment, while all men receive the placebo. The major problem with this design is that gender and treatment are completely confounded. If we observe any difference between the groups, we won't know if it's due to the treatment or simply due to gender differences. This makes it impossible to draw valid conclusions about the treatment's effectiveness. Now, let's look at a better approach, the completely randomized design. In this design, we pool all subjects together, both men and women, and then randomly assign each person to either the treatment or placebo group. The key advantage of randomization is that it tends to balance out the effects of gender and other variables between the groups. On average, both groups will have similar compositions. However, this approach has limitations. If our sample size is small, random chance might still create imbalances between the groups. Next, let's examine the randomized block design. In this approach, we first divide our subjects into blocks based on a key factor, in this case gender. We create a block of women and a block of men. Then, within each block, we randomly assign subjects to either the treatment or placebo group. The advantage of this design is that it guarantees balance on the blocking factor. We'll have equal representation of men and women in both the treatment and placebo groups. This design is particularly important when we know in advance that a certain factor, like gender, age, or disease severity, might affect the outcome. Finally, let's look at the matched pairs design. In this approach, we either match subjects who are similar to each other or we measure the same subject before and after treatment. For example, here we're measuring the same 3 people, Alex, Bob, and Chris before and after treatment. The big advantage of this design is that it controls for all characteristics that are the same within a pair, including factors we might not even have thought to measure. This design works well in situations like testing weight loss treatments, pain medications, or educational interventions where we can measure the same subject at multiple time points. Let's summarize the key takeaways for controlling variables in experimental design. Randomization breaks the link between treatment assignment and lurking variables, spreading their effects roughly equally across groups. Blocking and matching go further by ensuring exact balance on important factors you know in advance. Always include a placebo or some control group so that you can separate true treatment effects from other influences. By carefully choosing your sampling scheme and including appropriate controls, you maximize your chance of attributing any observed differences correctly to the treatment itself and not to confounding factors. This attention to experimental design is what makes the difference between misleading results and truly meaningful scientific conclusions. Thank you for watching this lesson on experimental design. Remember that how you collect your data is just as important as how you analyze it. With proper experimental design, you can have confidence in the conclusions you draw from your statistical analysis.